And then plugging these in, we should get c equals -2. So let's just check that right quick. 4 minus 2 is 2, so yes, it works. Okay, well, what do we do with this information now? Well, we're going to simplify. Let's see, so a was 1, so we get 1 over s. B was 3, so plus 3s minus 2 over, and now I'm going to go ahead and write it as a completed square. Because ideally I want to transform back into the t variables. The problem with that, or the problem with this version, is that in order to transform, we must have the s plus 2 everywhere. Everywhere there's an s. So right here, that's not written as an s plus 2. So I have to make it s plus 2. It's not terrible to do this, but it's something that at first you might not see to do. So I'm going to write s in parentheses. I didn't mean to erase the 3. I'm going to write the s in parentheses, and then I'm going to add 2 to it, but I can't change the value of anything, so I'm going to add and subtract 2. Here, that's a 0, so this is still just s. And then I still have my minus 2 from up top here. And now I'm going to collect terms such that the s plus 2 is everywhere. So I'm going to just group these two together. Maybe I'll put a green box around them so you can see that a little better. And now I have to distribute the 3 through still. So 3 times -2 is -6. Minus 2 is -8. So I'm going to get minus 8 over s plus 2 squared plus 1. And now I'm ready to transform back into the regular variables, the t variables. The inverse Laplace transform of 1 over s is a constant. In this case it's 1. If I took out the plus 2's, this would be s over, well, so 3, s over s squared plus 1, which looks like cosine. If I shift the s variable, it gives me an exponential in the t variables. In this case, it's e to the -2t for this 2. And then it just looks like cosine, so cosine of 1t. Minus 8 times, if this were 1 over s squared plus 1, it would just be sine of t. Since everything is shifted -2 units, it's e to the -2t sine of t. And that's it.